ladies and gentlemen.
So let's connect the different forms of quadratics to the graph of a quadratic, which is a lovely parabola, or, more commonly known as the U shape for many of my students. So we have three major forms for quadratics. We have standard form, which is your ax squared plus bx plus c. And in this form, the c is the y-intercept. That's a really only big piece of information you get. Vertex form is a times x minus h squared plus k, where h comma k is the vertex. Vertex being, the very top or the very bottom of the parabola. And factored form is a times x minus r sub 1 times x minus r sub 2, where r sub 1 and r sub 2 are roots or x-intercepts. You may have seen that with a p and a q. You may have seen that in a couple of different ways depending on the curriculum you use, the textbooks you're used to. But I like the r sub 1, comma r sub 2 because those basically tell you these are roots. So let's get started. So if I have a quadratic in standard form here and I want the vertex, I don't get that quite nicely from this equation. But I do have a trick up my sleeve. The x value of the vertex I can always get from standard form, which we do call this h. We get that from negative b divided by 2a. So if I take the b value, make it the opposite sign, and divide that twice the a value, that gives me the x value of the vertex. It's a formula you got to memorize. There is another way of going about it, but it takes significantly more time. So it's always nice to have some tips and tricks to help us. So here, the a is 1, the b is negative 8. So that means that h, or the x value of the vertex, is positive 8 or negative 8 divided by 2 times 1, which is 2, or 4. How do I get the y value? Well, if I have the x, I can plug it in and that'll tell me the y. So what I can do is I can do y is equal to 4 squared minus 8 times 4 plus 15. 4 squared is 16. Negative 8 times 4 is negative 32 plus 15. Well, 16 and 15 make 31 minus 32. Very easy to see that as a negative 1. So the vertex is 4 comma negative 1. Not too bad if you know the trick. That one, there is a trick to it, and if you know it, it makes life so much better. The next one is shifting the graph around. So if you have notation like this, you have something happening on the inside, you have something happening on the outside. So how I like to tell my kids how this works is if it happens on the inside, it affects the x's, or the horizontal aspect of it. If it happens outside, it affects the y's, or the verticality of it. Y's are quite simple. They're straightforward. A plus means up, a minus means down. But for x's, well, I think we've all been there. X's are crazy. That's why they're x's. So they do the opposite. So a plus actually means we go left, and a minus means that we go right. So if I look here, we have a plus 3 on the inside, which means left 3, and we have a minus 4 on the outside, which means we're going down 4. So if it happens inside, it affects the x's, and it does the opposite of what you think because our x's are crazy. And if it happens on the outside, it happens vertically, up and down, and it happens just normal. Plus means up, minus means down because y's are y. Now, the two major forms for graphing that you're probably going to be asked to do at some point would be standard form and vertex form. For both of them, the a value is the same. In fact, if I go up all the way up here, all of these a's are the exact same value. So if it was a 2 here, it's going to be a 2 here, and it's going to be a 2 there. All of those tell you where the ends of the graph are going. If the a is positive, the ends of the graph are going up. You have a regular U shape. Both ends are going up. If a is positive. If a is negative, the ends of the graph are going down. So it makes a like lowercase n shape. The line of symmetry, well, parabolas are very beautiful shapes. They have a curvature that is mirrored on both sides. And where that mirror is right down the middle through the vertex, the x value of the vertex to be specific. So the line of symmetry is x equals the x value of the vertex. For vertex form, it's really easy because that's just h. For standard form, we use that negative b over 2a for that. The vertex itself, negative b over 2a, comma, plugging in negative b over 2a. Or, if you have vertex form, it's h comma k. Quite nicely for that. How do you find the y-intercept? Well, in standard form, it's given to you. It's c. And in vertex form, you have to plug in 0 to figure it out. Now, the reason that we use vertex form a lot when it comes to graphing, or we like it more when it comes to graphing, is again, if I subtract on the inside, I'm moving it right. Adding on the inside, I'm moving it left. And if I'm adding on the outside, I'm moving it up. And if I'm subtracting on the outside, I'm moving it down. So very easy to see where the graph moved and how the graph shifted. So there we go. Last problem I have for us today is to write an equation in factored form with a vertex at -1, 10 and zeros of -6 and 4. Well, factored form is f of x is equal to a parentheses x minus r1 times x minus r2, where the r1 and r2 are our roots. Well, they tell us what the roots are. They're zeros at -6 and 4. So this r is going to be -6. This r is going to be a 4. So we get a times x minus -6, or plus 6, times x minus 4. But we're not done. We're not done because we don't know what the a is. But they gave us an extra point. They gave us the vertex. So we're going to plug this in for x and this in for y and see what happens. So f of x is our y here. So this is going to become 10 equals a, because we still don't know what that is, times -1, -1 plus 6 times -1 minus 4. -1 plus 6 is 5. -1 minus 4 is -5. So we get 10 is equal to a times 5 times -5, or -25a. And then we can divide by 25. So we have 10 over -25 is equal to a. We can clean that up a little bit because 10 and 25 share a common factor of 5, leaving us with a is equal to -2/5, or -0.4 if you like the decimals. I like the fractions though. That is it for us. If we have any questions, let me know. Otherwise, I'll see you in the next video.